Hello everyone. This video is on world's best universities, colleges in the field of electrical and electronics. Here you can see world's best universities in the field of electrical and electronics engineering. In the first column you can see the overall university ranking. In the second column it's specifically for electrical and electronics domain. And third column is NTU ranking, which is also called as performance ranking of scientific papers for world universities, which is a ranking system of world universities by scientific paper volume, impact and performance output. In the second row, University of California, Berkeley, the overall ranking is 27, but it doesn't mean that it is not good in electrical domain. It is ranked third as per QS, and its NTU ranking worldwide is 2. You can go through this page. So let's see very first university, Massachusetts Institute of Technology, and its department EECS. Area 1 is for electrical and electronics, area 2 for computer science. Area 1 has 4 categories: information systems, circuits, biomedical services, and applied physics and devices. Next is Stanford University. Stanford University's electrical engineering has various research programs under physical technology and science, information system and science, hardware software systems, biomedical, and energy. You can see here that integrated circuits and power electronics is a major chunk. These are the core areas. Different page, but we have already seen this. Next is affiliates, facilities and institutes. Let's see what Stanford has to show.
Electrical engineering has had a tremendous impact on our society.
We're trying to make the major more accessible to more people.
Well, this class is going to be radically different from previous classes on the same topics.
They do get a kick out of building things in the lab.
We decided to make major changes to some of the existing courses and to develop new courses that expose the students to the amazing array of applications and tools that electrical engineering provides.
California Institute of Technology, shortly called as Caltech. It is privately funded college and has a lot of funding. Its research areas include bioelectronics and biooptics, electromagnetics, optoelectronics, robotics, signal processing, MEMS, circuits and VLSI, etc. You can see the facilities here. As there is a lot of funding, the facilities are top class. There are many research centers as well: IQIM, IST, CACR, Lee Center. Let's see what Caltech has to show. Very well known Harvard University, and it has a department John Paulson School of Engineering and Applied Science. There are many interdisciplinary research areas including applied mathematics, applied physics, bioengineering, computer science, electrical engineering, and under electrical engineering we have circuits and VLSI, computer engineering and architecture, robotics and controls, Signal processing. Berkeley, a public college under University of California. Its electrical, electronics, and computer science department has a lot of research areas related to electronics, physical electronics, and then micro nano electro systems, MEMS, integrated circuits, etc. This is the college where I saw the most number of research centers and labs. Berkeley Deep Drive, Berkeley Emerging Technologies Research, Berkeley Sensor Actuator Center, Energy and Environment Center, Center for Energy Efficient Electronic Science, then CITRIS Sustainable Infrastructure, Electronic Material Program, and lot many. It also has a good competitive atmosphere. Let's see a part of it.
This program is fantastic, and I hope that we can participate again next year.
I wish I could attend this every day of my life.
Nanyang Technological University, Singapore. Electrical and Electronic Engineering Research in NTU. It is one of the best college under this subject, electrical and electronics. Instead of going through their website, we can directly jump onto their promotional video, which has a lot to show.
Our industry needs people who are passionate, who go beyond the limits, who don't accept something cannot be done.
To find a very difficult challenge that they can solve, but where it has got a global demand.
Think about the kind of impact that you can make.
Given a chance to go back, will I take up engineering career? I think the answer is yes.
National University of Singapore, an autonomous research university, is the largest university in the country in terms of student enrollment and curriculum offered. Its electrical and computer engineering department includes research areas such as communication and networks, control intelligent system and robotics, integrated circuits and embedded systems, microelectronics, microwave and RF, power energy system, signal analysis and machine intelligence. It has several departments, research centers, MEMS, green energy management, optical science, satellite technology and research center.
In NUS ECE, our aim is to empower students, to train them to be professional engineers who can help to contribute to solving some of these major societal problems. Electrical engineering will also contribute to solving the problems presented by climate change through the electrification of vehicles, cars, buses, trains, aeroplanes, and even ships of the future. And these intelligent transportation systems will require us to have telecommunications or informatics to control them, sensors to allow us to sense the location and the environment and so on, so that cars can intelligently interact with one another, as well as with pedestrians and the infrastructure.
You have this renewable energy coming in that's so intermittent in a way that whenever you need it, it might not be there for you. So smart grid is a vision that you can have the ways to control and manage all these energy options better.
We have now one of the world's best solar energy institutes. It's an amazing technology in the sense that it combines a lot of different fields. It's very multidisciplinary, so it's never boring. And you can do wonderful things, for example, powering Singapore and the world with clean electrons.
In the last 20, 30 years, we have developed technologies that enable us to see things at atomic level, right? So we can today visualize atoms, we can see single atoms, we can even move a single atom on a chip, I can take atoms and arrange them into like a Lego pattern, arrange them. We have such capabilities today.
In nanoelectronics, we make devices which are miniaturized and they are more power efficient and computationally faster. We enable the making of chips with more functionalities, like being able to smell, to see, and to hear.
Robotics is absolutely fun. You wake up in the morning thinking what will happen for the whole day, and you see robots being built, technologies being created. Interestingly, the more I build robots, the more I learn about humans.
One of the things that we're trying to develop now is for ways to record the signals from the body and then use those signals to help the person regain mobility. So that allows them to actually move, allows them to interact with the world.
We are working on the developments of UAV with advanced operational capabilities such as fully autonomous flight, waypoint navigations and obstacle avoidance. It can be sent into a collapsed building to gather informations or visualizations of the interior of the buildings sent out to the rescuers outside before the rescuer even go into the building to rescue.
For me, I think the most exciting point for my research is that I try to solve the problem from real life. For example, a lot of people with this kind of issue are how to dress properly, right? Yeah, and also for the young lady, maybe quite difficult for them to understand what I should do to make up for the day, right?
We take the images along a street, like those Google Street View images, and then we extract the 3D information from those images. Then we can reorganize those point clouds into texture mapped 3D models. Those models, they are virtual representations of the real world. They can be used for map services. They can also be used to create imaginary sceneries in games or movies.
In general, extremely good at several things. One, it has the world-class pool of faculty here. Two, it draws from the global pool of students, so it has some of the best students. And of course, it has one of the finest infrastructures. So it's a combination of all these things that makes, I believe, ECE a very unique place for students to come and join and learn, and at the end of the day, realize their own dreams.
University of Cambridge, a public university in Cambridge, England. Its Department of Engineering has sub-department Electrical Engineering, which has several groups like solid-state electronics and nanoscale science, electrical power and energy conversion, and various laboratories such as bioelectronics, Center for Advanced Photonics and Electronics, Cambridge Innovation and Knowledge Center, Cambridge Graphene Center, Nanoscience Center, and Center for Innovative Manufacturing in Large Area Electronics. It has research groups like Electrical Power and Energy Conversion Group, Photonics Groups, Solid State Electronics and Nanoscale. It has research facilities in Electrical Engineering, a clean room, which is a facility ordinarily utilized as a part of specialized industrial production or scientific research, including the manufacture of microprocessors.
What makes studying engineering at Cambridge special is that we teach fundamental problem solving. Cambridge students can be given almost any problem and can break it right down to its basics and solve it.
The Dyson Center is another unique facility where students can actually design and build prototypes of whatever idea they have, and it's just a wonderful opportunity.
Another particular advantage of studying engineering at Cambridge is that we sit at the heart of one of Europe's most successful clusters of innovative startup companies. Students here have numerous opportunities to engage with those innovation-based activities.
You will find in fourth year that everybody is trying to recruit you. There is so many opportunities. Personally, I'm hoping to apply for the graduate scheme for the European Space Agency. That's something that's always fascinated me.
University of Zurich, university in Switzerland. It has a department at master's level. It is called as Electrical Engineering and Information Technology. Its specializations are communications, computer and networks, electronics and photonics, energy and power electronics, system and control, signal processing and machine learning. Now let's see research area. Basically you can do research in all the area which were there in master's program. Then there is something doctorate. Okay, the same thing, a Ph.D. degree. Programs and initiatives. There are certain programs we will see only which are related to electrical and electronics, digital fabrication, molecular, ultrafast, quantum science and technology, robotics. Then power supply of electrical energy. University of California, Los Angeles. A university with many scientific breakthroughs. These three categories will be explained in details in this clip.
The Electrical Engineering Department at the UCLA Henry Samueli School of Engineering and Applied Science is better positioned than ever to address the technological challenges of our society. The department is comprised of 37 research groups and 9 research centers and institutes, which are populated by close to 50 faculty members, 400 graduate students, and 600 undergraduate students.
The electrical engineering department at the UCLA is a highly dynamic environment. We're committed to excellence in both teaching and research. Through partnership with government agencies and the industry, the level of research funding has been in excess of $25 million a year. This level of the support speaks loudly to the quality of the research activities that are pursued by our faculty members.
Research and education activities span 3 interdisciplinary areas that make up the electrical engineering department. These areas are circuits and embedded systems, physical and wave electronics, and signals and systems. The circuits and embedded systems faculty converge on research focusing on low-power electronics, communication circuits, integrated circuits, and other areas. An example of a major industry breakthrough with close ties to the electrical engineering department was the work by Professor Henry Samueli on broadband communication circuits. This led to the creation of Broadcom, another major industry player in the wireless revolution.
There would be no Broadcom if it wasn't for the basic foundation of knowledge that I learned not only as a student, but then evolved as a faculty member working with then my new students who had joined as master's and Ph.D. students to help me build a research program. It is that creation of knowledge in a stimulating environment with world-class students, world-class researchers as your partners and collaborators that's truly unique.
Several research labs comprise the circuits and embedded systems area, such as the Parallel Data Architectures group of Professor Dejan Markovic.
My research is focused on energy-efficient integrated circuits for future communication and healthcare devices.
Several regular and associated faculty are members of the National Academy of Engineering and the National Academy of Sciences. Professor Patel from Physics and Electrical Engineering is also a recipient of the U.S. National Medal of Science. 32 of our faculty members are fellows of professional societies in their fields of expertise. Physical and wave electronics make up the second research area in the department, which covers a broad range of fundamental subjects involving deep space communications, electromagnetics, nanotechnology, and other areas.
Here at the UCLA, we have 2 national centers. They're funded by a consortium of semiconductor company as well as federal government. Our research focuses in the area of nanomaterials, devices which are the elements to make smart, energy-efficient electronic systems. This is what will be the future of electronics based on nanotechnology.
Assistant Professor Idagon Ozkin's research has already received several accolades and broad press coverage through the New York Times, the BBC, and other venues.
What we envision is these advanced equipment to be simplified. What you see here is a regular cell phone that you use, except that they're modified with less than $10 worth of parts. We envision having the blood of the patient put on a simple microscope slide. The sample is loaded to the cell phone through the side, just like you insert a memory stick. As simple as that, we've captured the images of the cells.
Professor Chan Joshi, another faculty member in the physical and wave electronics area, has made fundamental contributions to our understanding of extremely nonlinear optical effects and plasmas.
We are working on a new technology using plasma, which is ionized gas, as a medium to build high-energy accelerators for the 21st century. This work is important because it will lead to accelerators of the future. These accelerators are needed for exploring the nature of matter and forces.
The third research area in the department is signals and systems. Faculty in this group are advancing research in many areas, including communications technologies, speech, image processing, and adaptation and learning. Professor Jin Lee's biomedical imaging lab analyzes humans' largest circuit, the brain, and searches for new therapies for brain disease.
My lab works on developing technology to develop methods to systematically analyze how the brain functions. The brain is a very complex circuit that makes it very difficult for us to know what it's doing, which also makes it difficult for us to find understanding and cure for the different brain disorders, such as Alzheimer's, Parkinson's, and depression. These are the diseases that we're looking at currently to provide systematic analysis and debugging options where we develop therapies.
The research of Professor John Villaseñor extends into the areas of hardware security and wireless communication.
One of the things that we're looking at and spending quite a bit of effort developing are methods to make sure that if a hardware attack actually does get launched from within an integrated circuit in a device that's already out in a product or in the field somewhere, that attack can be identified and stopped and appropriately dealt with in real time as it's occurring.
Professor Mahela Vandashar, faculty member in Signals and Systems, has published extensively on multimedia communications.
We are doing work on systematic foundations and theories for multi-user communication systems and networks. For example, we are looking at how multiple cell phones or wireless devices can autonomously coordinate to share a particular wireless spectrum. This is very important in today's communication systems because more and more users are sharing the same amount of spectrum at the same location, and hence they are competing for these resources.
Research at UCLA Electrical Engineering has been a catalyst for discoveries that have led to modern-day advancements. Many former students and faculty have launched companies that have become industry leaders and innovators. Some department breakthroughs include the work of former Professor Andrew Viterbi, who revolutionized the area of digital and wireless communications through the development of the Viterbi algorithm and the founding of Qualcomm, a major industry player in the wireless domain. Other breakthroughs include the work of Professor Henry Orchard, who developed computer-aided filter design tools, and Professor Asad Abidi, who developed the first CMOS radio.
IIT Bombay, the best institute in India to study electrical and electronics engineering programs such as communication engineering, control and computing, electronic systems, etc. Ph.D. Deputy of going on. IIT Delhi, the premier institute in northern India. Its Center for Applied Research in Electronics has different research areas like microwave, microelectronics, signal processing, and technology transfer. Its microwave lab has CAD lab, measurement lab, mask making and IC. It has microelectronics lab, signal processing lab, speech and audio processing lab, UWA lab, and NP mask lab. IIT Kanpur, it has National Center for Flexible Electronics. Its specializations include control and automation, microelectronics and VLSI, photonics, power engineering, RF and microwaves, signal processing, communication and networks. Next, we will see Indian Institute of Science, Bangalore. That institute does not have any bachelor degree courses. It is dedicated for masters and PhDs, specifically for research purpose. So let's see it. Indian Institute of Science, Bangalore. It has many labs and research groups. Wireless Research Lab, VLSI device, Applied Photonics, Microwave Lab, Embedded Sensing, Communication and Processing, Wireless Information Systems, Next Generation Wireless Lab, Optics, Nanostructures, Analog and RF Systems, and so on. And research facilities. Yes, as it and the topmost institute in India for research, the facilities is definitely top class.
So let me start by introducing our department. If you see the first slide of my presentation, you will notice that we were established in 1947, and we have spent about 7 decades in the field of communication, signal processing, microelectronics, microwaves, and photonics. So our goal is to pursue excellence. So if you look at our next slide, the research areas which we are currently pursuing, if you start on the top, it's communication, networks, we do interdisciplinary research, microelectronics, nanoelectronics, RF, microwaves, photonics, and signal processing. So the nature of work and research and other activities, industrial interaction and applied research will depend upon individual faculty interests, as well as sometimes interest from the students themselves, who may want to pursue something and they trigger the faculty's interest. And we are open to listening to students' views and working together and pursue a new field, which need not be listed here. Next slide. So the themes, okay, so the faculty composition, basically we have about 11 professors, 5 associate professors, 7 assistant professors. We have 3 principal research scientists. We have scientific officers, visiting professors, and associate faculty. So associate faculty members are basically faculty members from other departments in the institute who are attached to ECE department. For example, we have 1 associate faculty member from the Center for Neuroscience, and there is interest in this department of doing neuroscience and bioengineering related work. The faculty have a very rich experience and have graduated from the top schools in the United States and other parts of the world. So if you look at the next slide, you will see that faculty have graduated from Brown, Carnegie Mellon, Caltech, Cornell, IISc, IIT Kanpur, MIT, Penn State, Princeton, Purdue, Sheffield, Stanford, Texas A&M, TFR, Maryland, Michigan, Southern California, UT Austin, University of Washington. So you can be assured that you will be interacting with people who have experienced different systems, the Indian systems and the non-Indian systems, and universities which are at the forefront of technology and research globally. The faculty members are very active in research and are very well recognized globally and nationally. This slide gives you an indication of the recognition by various academies in the country, like fellowships of national academies. We have all 19 fellowships, that is faculty members hold multiple fellowships of different academies in the country. We have the World Academy of Sciences Fellowship. We have IEEE Fellowship, which is an international society. Faculty members are editors of various top journals, research journals, which are basically IEEE journals, CIAM, Elsevier, Springer, etc. We have a lot of faculty members who have won awards, like the Inspire Fellowship, J.C. Bose Fellowship, Swarna Jayanti Fellowship, and so on and so forth. So this basically indicates that how active our faculty members are. We are as good as any top university in the world in this field of electronics and communication engineering. So the students, the next slide indicates the composition of the students. So typically you will see that the department has a lot of students who are pursuing their PhD, which includes research students who are regular students, as well as people from industry and students who have working in academic institutions, that is, who are faculty members who want to pursue their PhD, and external registration program students who are basically from R&D labs and industry. But the core, you can see that the bulk of the students are PhD students. And then we have these MTech students. We have MTech in communication networking, networks, signal processing and microelectronics. And then we have MTech research, which is the...
Finally, IIT Madras. Its major research themes include communications, power engineering, analog and digital, VLSI, micro nano, control systems, photonics, and research laboratories. So bringing back this page again here, I hope I have covered almost all major electrical and electronics engineering colleges in my video. But still, if you think that I have missed some of the colleges in this list, kindly let me know by commenting below. Thank you for watching.